Art in the plane, no, not the kind that flies. I mean a flat surface of infinite size. First is internal half-turn symmetry. You're going to have to use your mind and think of this visually. You take a point that lies on the line with a 180-degree turn. It should all align. On a curve, this could work at a point, but only one. With the straight line, it works at every one. In geometry, this is very conducive, because now we got a property that we can call exclusive. Now let's go to internal perpendicular reflection. Compare it to the last so we can make a connection. For this, we also need a point to assign. So once again, let's take a point that lies on the line. Now let's cut down through with a line that's very particular. Its slope is the opposite reciprocal, yet perpendicular. This works for straight lines, but can also work for curves. A parabola and circle are examples of where this occurs. With this property, we can be very conclusive. To straightness, this is not exclusive.
What's your definition? Let's investigate Trig's proposition. We're going to use some symmetry that you never knew. It's going to be a breeze on left 42.
Now I hope you understood everything on the plane very clear, because we're going to complicate it a little. Let's travel to the sphere. Straightness might not be what you previously viewed, so let's start by looking at lines of longitude. To do this, let's think through the mind of Steve Urkel. By longitude, we mean a great circle. If you don't understand, I'm going to set the parameter. A great circle travels through opposite poles of the diameter. Internal half-turn still holds to be true, but we're on a curved surface, so is this new to you? Internal perpendicular also worked here. Since it worked for the circle, it must work for the sphere. I think you get the picture, so I'm going to be shrewd. Let's switch on over to lines of latitude. This is not a new picture, not a new world view. Latitude is any circle that is not a line of longitude. Still staying true is internal perpendicular reflection. When we do this, the lines travel in a perfect direction. But internal half-turn just doesn't work out. Check out the picture if you have any doubt. And I had a picture on that, but you guys
What's your definition? Let's investigate. Here's my proposition. We're going to use some symmetries that you never knew. It's going to be a breeze. Now let's explore too.
So longitude is straight, but latitude is not. Is this a little different than what you previously thought? Latitude lines might look straight on a map, but this isn't true. We can't go by that. If straightness is what we truly believe, we got to prove it using our symmetries. Lines can be straight on the plane or the sphere. To investigate, just apply what you learned here.